Okay, so we will start. So here you got it right. How to prepare iron 3 chloride? Anybody tell? Yes. How to prepare iron 3 chloride? What we have to do? Yes, Sophia. Go ahead.
I don't think I was there in the last class.
The last thing. Okay. So how to prepare this? Tell me. Ruth?
Uh,
Anybody?
I'm saying that I wasn't there in the last class.
Isn't there? Okay, you was there. Okay. Rudra, you was there, right? Come on, tell. Tell, I'm waiting.
Oh, yes, ma'am.
Hmm. Tell me how to prepare this.
So you put chlorine through a tube in
Hmm.
a beaker, and then in the beaker there's
Okay.
concentrated H2SO4.
Okay. Let me explain. So here in this iron 3 chloride, what we have to do first, when it will break with water, it will produce two things, right? It will produce these two, H plus and OH minus, right? Yeah, sorry. So here what we have to do when it will break with water, H plus and OH minus, it will also give this, because my iron chloride is what? Fe is what? Iron. And what is chloride? Chloride is Cl3. It means FeCl3. So it will break in these two also. Fe3 plus and Cl minus. Okay. When it will break with water, it will break with these two things. H plus and OH minus of water, and Fe is for Fe3 plus and Cl minus. Now how to prepare this? So what we have to take, see here, this is my container. So first we took a container and then we put concentrated H2SO4. Okay. This is what? This is my concentrated H2SO4 which is there in my container. Okay. So here what we are doing, chlorine is taken from outside as a supply. We are taking this chlorine as a supply from outside. Now what we are doing, after reaction, what will happen? Your moisture will be removed. See, when we will pass chlorine from this chain, okay, from this supply path, then what will happen? When chlorine will mix with this H2SO4, then what will happen? Then whatever the moisture is present in your chlorine, that will be removed. Okay. So to remove the moisture of chlorine, we have to pass it through concentrated H2SO4. Okay. Understood? Till this
Yes.
much, till this part, have you got it? It's
Yes,
easy
ma'am.
only. See, we have to take chlorine from outside. We have to mix chlorine with concentrated H2SO4. If we will mix chlorine with concentrated H2SO4, then what will happen? Your moisture, whichever amount of, like, some amount or large amount, small amount, whichever amount of moisture is present in the chlorine, that will be removed. Now, what will happen? Moisture removed due to this H2SO4, it became dry. Now in your Cl2, if moisture is there, okay, and if moisture will be removed, then what will happen? Your chlorine will become dry. है ना? So when it will become dry, then dry chlorine will pass it through this chain, okay, this box. It will pass it through this till this much, okay, till here it will pass. Now what will happen? It will pass through this iron. This is what? This is round part is my iron wire. Okay, then dry chlorine will pass through this iron wire, and when we will heat it now, when we will heat my iron wire, then what will happen? Chlorine and iron will react. See, this is my iron wire which is there in this box. Okay, we are passing dry chlorine from this iron wire. Then what will happen if we will give more amount of heat to my iron? Then what will happen? These two, chlorine and iron, will react. Then what we will get? When it will react, then we will get a iron chloride. This is the reaction. Where is it? Yeah, this is the reaction. 2Fe plus 3Cl2 is giving 2FeCl3. Okay, which is highly deliquescent. What is deliquescent? Deliquescent means it will absorb moisture from atmosphere and it will dissolve in that. Means some amount of moisture is present after passing through this diluted H2SO4, sorry, concentrated H2SO4. Then also your some amount of moisture is present. Then what will happen? Any idea? See, here is what, this is my fused calcium chloride. Okay, if we take so in one tube, this is my tube. Okay, this is what, this is my tube. So in one tube we put this fused calcium chloride. So the moisture which is present in that chlorine, it will absorb all the moisture. Okay, so then we will get what? Then we will get a dry iron chloride. So now let me explain you again. See, this is my beaker. Okay, in beaker there's what? There is concentrated H2SO4, and we are passing this chlorine from the supply chain. Okay, from the supply, the thin from this thin part we are supplying chlorine, and here in this beaker there's concentrated H2SO4. These two will combine. The chlorine and concentrated H2SO4 will combine, and when it will react, then what will happen? The whichever moisture is present in chlorine, it will get removed. Then what will happen? Then if moisture is removed, then only the chlorine is left with dry thing. Okay, then dry chlorine is left. So then dry chlorine will pass it through here, 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 here. Then what will happen? This is my box. In this box there's an iron wire. Okay, and it might,
Mom,
huh,
Mom, is the same process used for preparing calcium oxychloride? Because in that also we need dry chlorine.
what? Not
Um,
all same, but somewhat.
okay.
Okay, so here in this box, these two are present, the chlorine and iron, and it will heat iron. Then what will happen? These two will react, and we will get this. After reaction, 2Fe plus 3Cl2 will give 2FeCl3. Then also, some amount of moisture is present. So with the help of this fused calcium chloride, which is fixed in your this tube, what will happen? Your whichever moisture is present in your what? In your chlorine, it will get removed. Okay, then what you will get? You will get solid Fe3, which is free from moisture. Okay, got it? Now, what is next? Next one is this one. What is this? How to prepare zinc sulfate. So it is an inorganic compound with a formula ZnSO4. We know zinc is Zn, sulfate is SO4. So we can also call this zinc sulfate as white vitriol. Okay. So we also call this as white vitriol. So how to prepare this zinc sulfate? Zinc sulfate is produced by treating any zinc containing material with sulfuric acid. So what we have to do? Sulfuric acid is what? H2SO4, right? So what we have to do? We have to zinc sulfate is produced by treating any zinc containing material with sulfur. Like here, this is what? This is Fe is what? Fe is iron. So iron is reacting with H2SO4 giving FeSO4, right? Iron sulfate and H2. H2 is evolved. So that's how the zinc sulfate is formed. Now, what is next? Next is your calcium chloride. What is how to prepare calcium chloride? Any idea? Hmm? So see, sorry, calcium carbonate. I'm saying calcium chloride. Okay, calcium carbonate, CaCO3. It is formed by three main elements. One is your C is your carbon. Okay, your Ca is calcium, and your O is what? Oxygen. Means it is formed by three main elements: your carbon, your oxygen, and your calcium. And it is what? It is insoluble salt. It is not soluble. It is insoluble. Now, how to prepare this? It can be prepared by mixing the solutions of calcium chloride. Means this is my calcium chloride and sodium carbonate. Okay, what we have to do? This is simple one. Only we have to mix two things. One is calcium chloride, CaCl2, and the another one is sodium carbonate. Sodium is what? Na2CO3. This is my sodium carbonate, right? And after mixing, we will get this one: calcium chloride, CaCO3 plus 2NaCl. So that's how we prepare calcium carbonate, by mixing calcium chloride and sodium carbonate. Now, what is next? Next is your lead chloride. Lead is what? Lead is Pb and chloride is Cl2. So PbCl2. It is an inorganic compound with formula this, which we already know, which is a white solid. Okay, your lead is what? Lead is white solid, white in color. And it is one of the most important lead-based reagents. How to prepare this? It can be obtained by mixing solution of lead nitrate, this is your lead nitrate, and diluted hydrochloric acid. So you have to learn all these, okay, how to prepare lead chloride, how to prepare calcium carbonate, how to prepare iron sulfate. So you have to remember all this. Make a note. So preparation is of this is simple: your lead nitrate and your HCl. And what about calcium chloride? Your calcium chloride and sodium carbonate. Now, what is your next one? Next is your sodium bicarbonate. Sodium is Na, bicarbonate means HCO3. Okay, so how to prepare this? It can be prepared by treating carbon dioxide gas with sodium carbonate solution. This is my carbon dioxide, this is my sodium carbonate solution and plus water. Solution means what? Obviously solution means water also, है ना? Means sodium carbonate plus water and plus CO2 also. It will give you what? It will give you sodium bicarbonate. So that's how we prepare this. Okay? Any doubt? Any doubt?
Could you show the equation for calcium carbonate again?
Yeah. See this. Okay.
Yes, ma'am.
See this also. Your lead chloride. Okay. So how to prepare this? Sodium bicarbonate, carbon dioxide, and sodium carbonate solution means plus water. Okay. So now what is next? Next one is this. Copper sulfate means CuSO4. How to prepare this? Copper sulfate can be easily prepared industrially by treating copper hydroxide CuOH twice. Your copper oxide use CuO or copper carbonate means CuCO3 with dilute H2SO4. So what we have to do here to prepare this copper sulfate, we have to treat copper with copper oxide, or we can treat with CuO, or we can treat with copper carbonate, matlab CuCO3. These three we have to treat with what? With dilute acid means H2SO4. So if we will if we will treat these three with your dilute acid, then what will happen? We will get CuSO4 as a product and some water and plus some carbon dioxide. Okay.
Ma'am, 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 like just copper with hydrochloric acid.
Huh. What?
Will,
Hydrochloric acid? Just
ma'am,
copper hydroxide.
if
Copper
copper
hydro.
if just copper reacts with hydrochloric acid, will it form the same product?
Yes. See here, it's forming now. Your copper hydroxide plus this thing is this. Either you can write this copper hydroxide, or you can write this copper oxide, or you can write this. So this is the easiest one, maybe the CuO, right? CuO plus H2SO4 giving CuSO4 plus H2O. This is the easy reaction. Okay, so CuSO4 formation is this one. Lead, zinc, calcium, lead chloride, and your sodium bicarbonate is this. And what about, and what is your next? Next is what? Next is your sodium sulfate crystal. Now, do you know how to prepare this sodium sulfate crystal? Anybody?
Sodium chloride with H2SO4.
Sodium chloride. Sodium hydroxide. Okay, so let me see. Here, what we have to do. So, sodium sulfate preparation. It is prepared by the neutralization of caustic soda with dilute sulfuric acid. 2NaOH is what? 2NaOH is my caustic soda. With dilute sulfuric acid, we already know which is H2SO4, right? If these two will react, we will prepare what we will get? We will get sodium sulfate and plus water. So here what we have to react is, see, two things, no? Caustic soda and sulfuric acid. Okay, so this is the procedure of preparation. What we have to, a titration is performed to produce this product. What is titration? What is titration? Anybody? Come on, tell me, what is titration? Okay. So in the next class, you two will explain me what is titration. Okay, Rudra and Sapya. Now here is what a titration is performed here. In your flask, 25 centimeter cube of sodium hydroxide solution is measured. So this phenolphthalein this indicator is added. Okay, then what's happened? The solution will turn pink. So these are the procedure to prepare this your sodium sulfate. Now what is this your general property of salt? Salt is what, when exposed at room temperature, they do not evaporate. Okay, okay, so when we take salt, like go to your kitchen and take salt. Okay, when we'll take salt in our room at a room temperature, then what will happen? It will not evaporate. Obviously, it will not evaporate. If I'll go in my kitchen right now and I'll bring salt, then what will happen? It's not evaporating, right? It will not evaporate. What? When it will expose at a room temperature. So this is the property. They readily form electrovalent compound. Salt is having the property of performing this electrovalent compound. Okay, they have high melting point. High melting point is a result of forming ionic compound. They have greater force of attraction. So between salts, what will happen? The salts will have greater force of attraction between the molecules. Okay, those substances that can remove water molecules even from compounds are known as dehydrating agent. So dehydrating agent is what? Your concentrated H2SO4 can remove what? Can remove water from your blue vitriol. So this is the also the property. Now next is what? Salt also undergoes into hydrolysis, right? Your strong base, sorry, strong, sorry, strong acid, weak base. So these are what? These are the phenomena of the hydrolysis. Now, are all salts soluble in water? Tell me, are all salts soluble in your water? All are soluble, okay, but there are some. Safia.
No, ma'am, all of them are not soluble.
Some are exceptions. Yeah, some exceptions also, such as all sulfide, and all carbonates. This I already taught you in the very first lecture. See here, yes. See, what are the exceptions? Where is it? See, these are insoluble salts. Your carbonates, bicarbonates, your sulfide, all are what? Insoluble salts, right? So these are what? These are the exceptions. Your sulfide, and your carbonates. And the examples of sulfide are Na2SO3, your K2SO3, your NH4 twice SO3, Na2S, K2S, NH4 2S, N2CO3, K2, and this one. Okay, so these are what? These are some exceptions. All your salts are soluble in water, but these three are the exceptions. So with this, your chapter is completed. Acid, bases, and salts. In the next class, tell me, Rudra and Safia, all the assignments are done. Any doubt in any assignment? Tell.
Uh, yes, ma'am, no doubt.
Rudra.
No, ma'am.
Okay, so this is done. In next class, I'll take then test. Okay. After this, which chapter is left? So this is your syllabus. No. Yeah, this is done. RNE and your ABS done. MET is left. MET is left now, and this is also left, right? But in your half yearly exam, till MET will come or till ORG or means carbon and its compound of. Tell me your syllabus of half yearly exam.
We'll only have metals and non-metals.
Metal and okay, till metal and non-metal. Huh?
Yes, ma'am.
Okay. And what about you, Rudra? Till?
Ma'am, metals and non-metals.
Okay. So in the next class, you guys will have test, and in the next, I'll start with this methods or non-methods. Okay. Okay then. Any doubt in this chapter? Any point? Anything? Baking soda, washing soda, everything is clear. Your POP, plaster of Paris, everything is done.
Yes, ma'am.
Okay. Okay then. Thank you. Bye bye.